5, 19 count numbers with non-decreasing digits. So for this problem, we are giving two integers L and R, represented as strings, and an integer B. So we're going to return the count of integers in the inclusive range of R and L and R, whose digits are in non-decreasing order when represented in base B. So this means, first of all, we're going to turn such count of numbers into base B. So for example, if base B equal to 8 for the first number, 23, it's going to be something like 2. Yeah, because 2 times 8 is going to be 16, and then it's going to be 7. It's going to be 2, 7. It's going to be the first bit for this L, and for this R, it's going to be 3 times 8, and 24, and 3, 4 is going to be the R going to be 3, 4 if it is the base B. This is going to be the first step, and then we're going to directly use the digit DP to solve the problem. Yeah. And now let's just use the template directly. Let me define a function tag. So this is just to turn any number. This n going to be an integer like L and R. We're going to turn this integer into a base B, and finally we're going to return a string. Yeah, let's just finish this part. So while n, we're going to use nm, going to be div mod with n and b, and result going to equal to string of the current mod plus the result. Finally, we're going to return the result. Yeah. Now let's just prepare two strings S1 and S2. So S1 going to be string of integer of L minus 1, and S2 going to be R. And now let's just finish the template of this DP. So we're going to define function f, and inside we're going to have the index, and here I'm going to prepare a array. Because we want to keep it non-decreasing, it's going to always be in increasing order. And here going to be its limit and its num. Yeah. So let me just finish writing the template, because here basically we don't need to think about it. We just need to finish our template. Yeah. So it's going to be the integer of its num. We're going to set the result to be 0, and if not, it's num. So we're going to reset the result to the next digit, I plus 1. Here going to be array, and its limit going to be false, and its num going to be false. Yeah. As we are going to use this string S1 and S2, so here inside of the function f, we're going to use a string S. So let's put it inside. Yeah. Now let's just check the low and high. So the low going to be 0 if it's num, else it's going to be 1, and high going to be an integer of Si if its limit, else it's going to be b minus 1. Yeah, so for example, if base b equal to 8, definitely the highest digit is going to be 7, so instead of 8. So this is why here is 7. So instead of 8, yeah. So this is why we're going to use b minus 1. Now let's just check that. Check all the digits from low to high plus 1. So if current digit more than or equal to the previous digit, so this means we're going to count it. Result going to plus equal to f with I plus 1, and here going to be the current digit, and its limit and d equal to high, and its num going to be true. Finally, we're going to return the result. Now let's just call the function. It's going to be f0. Here we're going to use a -1, or you can use a 0, it doesn't matter, but for me I'm going to use -1. Yeah, because the next number is going to always be more than -1, and its limit is going to be true, and its num going to be false, and inside it's going to be S2. And minus, let me just copy and paste. Yeah, so this is going to be S1, and the final result is going to modular a mod. So let me just use modular a mod. And this mod is going to be 10 to the power of 9 plus 7. Yeah, I think basically that's all about it. Yeah, it is a little bit more coding, but I think everything should be very clear. This is just to turn any kind of number, integer, into a base. So this is why I'm gonna call it maybe, yeah, I'm gonna call it as this. Maybe I'm gonna call it as a check function. Inside is gonna be integer of this one, and here I'm gonna use another check function and the integer of r. Yeah. Basically, I think that should be all good. And let me just run it. What is wrong? So here I forgot to put s inside. Yeah, now as you can see, it works. And now let me just submit it to check if it can pass. Yeah, as you can see, it passed for all testing cases, and it's pretty fast. Why it is so straightforward? I mean, basically we don't need to think about it too much. Yeah, because it is just a template problem. You just need to use the template and to solve it directly. Yeah, but before solving it, you must turn this kind of a string into an integer and turn it to a base b. After turn it to base b, you're gonna use the DB template directly, and the time complexity is gonna be here. Because this I gonna be basically it's gonna be dependent on the length of the L and R. Yeah, basically it is just 100. This I is 100. And for the array, because there are only 10-digit numbers 0 to 9, because b is 10, b maximum is 10, so this array is 10. So the time complexity is gonna be 100 times 10, and basically this is limit and its number is okay. And here we have another loop, low to high, so this means we're gonna have another 10. So basically the time complexity is gonna be 10 to the power of 4. That is why it always works. I think that's all about it. Thanks for watching. See you next time.